Okay, so today we're just going to be talking about heat transfer. Before we talk about heat transfer, I do want to take a look at this question here. Hopefully you've seen the last video when we talked about entropy. So the warm-up question today says, which of the following is not a situation which would lead to an increase in entropy? Okay, so see if you can answer that question. Okay, so just to remind you, entropy is very roughly a measure of the amount of disorder or disorganization in a system. Okay, and so let's go through one at a time. If you heat up a container of air, remember that temperature is a measure of the average kinetic energy of the atoms or molecules making up an object. And so if you heat up a container of air, think about what's going to happen to those air molecules. They're going to move faster. And if they're moving faster and they're bouncing around more often, that means they are less organized, they're less ordered, which means the entropy has increased. Okay, so A is definitely an example of an increase in entropy. Okay, B says sorting a package of M&Ms into different piles based off color. So again, you have to think of the situation and ask yourself, is this situation becoming more ordered or less ordered? If you take M&Ms and you sort them based off of color, that's becoming more ordered. Okay, that is not an increase in entropy, that is a decrease in entropy. And so this is actually going to be the answer to the warm-up question. If you shuffle a new deck of cards, obviously you're going to increase the amount of disorder in the system. Okay, so that would increase the entropy. And if you melt a block of ice until it becomes a pot of water, that's also going to increase entropy. And the reason is, if you think about melting from a solid into a liquid, in a solid the atoms or molecules are held together like really tightly and compactly. When you melt into a liquid, the atoms are still kind of held together, but they're not held together as ordered in such an ordered fashion. They're not like stacked in nice neat rows of atoms like you have in a solid. Okay, so going from a solid to a liquid or a liquid to a gas is going to increase the entropy as well. Okay, so the answer there should be B. Now, moving on to the notes for today. Today we're going to talk about methods of heat transfer. You should have learned about these methods of heat transfer in some of your other science classes. So we're just going to go over what they are. The links for the video are in the PowerPoint notes. I'll also post those in the assignment so you can watch those videos so that you can understand the differences between the three different methods of heat transfer. So remember that typically speaking, if you have two objects in thermal contact, heat transfers from the hotter object to the colder object until they reach thermal equilibrium and there's no net heat flow between them. And we talked about that before. Now, the way heat can transfer is typically one of three methods. You have conduction, convection, and radiation. So you've probably heard those terms before. We're just going to go over them really briefly. Conduction is the primary method of heat transfer within a solid. And the reason you typically see conduction with a solid is because in conduction, the way you transfer heat is through vibrations in the atoms. Okay, so basically what happens is you have atoms that are vibrating in a solid, and as you heat them up, they vibrate faster. And as they vibrate faster, they can collide with the atoms next to them, and through those collisions, transfer energy to those atoms next to them. Okay, so it says in the notes, in conduction, vibration from neighboring atoms is transferred from hot to cold via collisions. And again, you should definitely check out these videos to help you understand conduction. Now, the reason you only have conduction with a solid or with direct contact is because the whole purpose of transferring heat by conduction is that it involves the atoms colliding with each other. And that can obviously only happen if the atoms are pretty close to each other, which is why you typically see conduction with solids and with direct contact. You don't typically see conduction with a gas or with a liquid. It is possible, of course, but in a gas and a liquid, the atoms are pretty spread apart and they cannot collide with each other as easily. Okay, so some examples of conduction. If you put like a metal bar into a fire and the heat transfers through the bar from the fire into your hand and you burn yourself, that's an example of conduction. Touching a hot doorknob and getting burned when there's a fire, that's an example of conduction, because when you physically touch the doorknob, you're in contact with the doorknob. Those collisions, the vibration from the atoms in the doorknob can transfer to the atoms in your hand and burn you. Okay, and again, there's lots of examples of conduction. Just think of situations that involve, solids being heated or direct contact, and you'll have an example of conduction there. So again, check out these videos. They're meant to help you understand conduction. Okay, so convection. Convection is the method through which heat is transferred in a fluid, and when I say a fluid, I mean a liquid or a gas. Now, the way convection works is typically when you have a fluid, you have some parts of the fluid that are hot and some parts of the fluid that are cold. And what happens is hot fluid, like hot liquid or hot air, tends to rise and go up. And as it goes up and it cools down, it becomes more dense, and then it falls. And this is what's called a convection current. And if you check out the videos, or if you just Google convection, look at some images on Google, you can see some examples of convection. So, for example, hot air rising in a room that is on fire. Because heat tends to rise, hot fluids tend to rise up. That is an example of convection. If you've ever boiled water and you see the water kind of like moving around in circular motions, that is an example of convection, because parts of the water are hotter than other parts of the water. And so the hot parts rise, the cold parts fall, and you get this kind of fluid circular motion in the water. If you ever have held your hand above a candle or above a fire, you can feel the heat coming up from the fire even without touching the fire, and that's typically through convection, because the hot air above the fire rises and goes up into your hand if your hand is right above the fire. Now, again, I would definitely encourage you to check out all three of these videos. Just to look at some examples of convection, take a look at the situation. It says convection occurs when fluids, liquids, or gases move around due to temperature differences. So if you want to roast your marshmallow using this candle, and you want to use convection to roast the marshmallow, think about where you would want the marshmallow to be. And this is probably an obvious question, but see if you can figure that out. Do you want the marshmallow to be at position A, B, C, or D to heat it by convection? Okay, so clearly you want the marshmallow to be at position A to heat it by convection, and the reason is in convection the hot air is going to rise up, directly up off of the candle, like so, and it's going to go up and mostly go to position A. Now, obviously if you put the marshmallow inside the flame, that would be conduction. Now there's another way to transfer heat that we'll talk about in a second called radiation, and if you put the marshmallow at C or D or B, you'll still get some heat transferred, but you'll get less from convection and more from radiation. Okay, so let's go to the next slide. Just a few more examples with convection. If you've ever seen a lava lamp, those work using convection, because as there's a light bulb down here in the lava lamp, and it heats this kind of weird fluid inside, and as it becomes hot, it rises up as it loses density. As it goes up, it gets away from the light bulb that's down here in the base. Once it's up here, it cools down. And as it cools, it falls back down, and you just get that convection current that we talked about before. And so the last method of heat transfer we're going to talk about is radiation. Okay, radiation is the only method of transferring heat without a medium, okay, without a solid, liquid, or gas to go through. Now, just to be clear, you can transfer thermal energy, you can transfer heat through radiation through a medium. You do not have to have what's called a vacuum. A vacuum is basically an absence of a medium. Like space is a vacuum because there's nothing in space, it's just empty. Okay, you can transfer heat by radiation if you have a medium like air or water or whatever, but you don't require it. And so this is actually how we get our heat from the sun. Okay, the sun transfers heat to the earth through space through radiation. Okay, it can't do it by conduction or convection. Light bulbs tend to give off heat through thermal radiation. A radiator heating a room, your body being visible, and infrared imaging. All those are examples of radiation. And what you need to be aware of is that when we talk about heat through radiation, the focus is on the fact that all objects emit this electromagnetic radiation in the form of photons. A photon is a particle of light, and these photons hit other objects, they are perceived as heat. Okay, now what is not in here, which probably should be, is these types of photons are important. Okay, so let me tell you the type of photons. I'm just going to write it over here to the side. When we talk about heat radiation, we are talking about infrared radiation. Okay, infrared photons. Okay, there's lots of different photons. There's visible photons, X-rays, gamma rays, radio photons, whatever. When we talk about heat transfer, we're talking about infrared. Okay, so that is heat transfer by radiation. Now, just to see a few more examples, on this slide, we can see a pan being heated by conduction, convection, and radiation. Conduction is the handle getting hot, because remember, conduction involves atomic collisions in a solid, and because the handle is a solid, obviously heat can transfer by conduction there. Convection is the heat rising up from the logs into the thing. And the radiation, you can feel the heat from the fire even if you're standing over here to the side, not directly above the fire. And if you look at the picture on the right, you can also see some more examples of heat transfer by conduction, convection, and radiation. And then just one more quick example, or two more quick examples. In this example, it wants us to label where we see heat transfer by conduction, convection, and radiation. Okay, so let's start with this one up here. What type of heat transfer do you think should go in this top blank up here? Conduction, convection, or radiation? Okay, so this is actually going to be convection, and the reason is because it's above the flame. Remember, in convection, heat rises up, okay, because liquids and gases, when you heat them up, they become less dense and they rise up. Now take a look at this one down here. What type of heat transfer do you think this is? Conduction, convection, or radiation? Okay, so this is actually going to be conduction, because the spoon that's in the fire is a solid. Remember, you have conduction in solids because the atoms have to be able to collide with each other. And then over here we have heat transfer by radiation. Okay, and then just one more set of examples. It says label the following situations with the correct method of heat transfer. You should be able to do this on your own, but we can just go through really quickly. A metal knife gets hot sitting on top of the toaster. That is going to be conduction, so there's direct contact with solids. Your steak gets grill lines on it from where it touched the grill. Keyword there is touched. That's also going to be conduction. The heat you feel when you stand next to but don't touch a hot oven. So if you're next to the oven, and there's not direct contact, it could be conduction or radiation. But typically if you're standing next to something and not above something, it's going to be radiation. Okay, because those infrared photons we talked about, they can go in all directions. With convection, remember, hot fluids tend to rise straight up. Okay, so for example, these next two are both going to be convection because they both involve hot fluids rising and falling. So convection and convection. Sorry if you can't read those. Those last two both say convection. Okay, so you should have plenty of examples in your notes to better understand methods of heat transfer. You have an assignment to work on involving heat transfer in Canvas. So now finish taking your notes and then go work on that assignment in Canvas over methods of heat transfer.